Welcome back to Think Design Work Smart. I'm Alex Bolbok and I'm coming at you from the Mosaic Work Studios. And today I would like to talk a little bit about dependency injection, a design pattern that's very useful. And the reason I decided to talk about this is because there's a meme circulating Twitter right now. Stop doing dependency injection. Now, normally I wouldn't take this very much. I would find it very interesting and I wouldn't comment on it that much. But I know that every few years this industry goes through a reset, a phase when we say everything that happened before or in the past 5 years, well, usually longer than that, in the past 20 years or so, we erase it and then we say we'd like something new to replace what we've done before. And the thing with this is it's good on one hand because we are advancing the industry in certain directions, but on the other hand it also involves a lot of rebuilding, redesigning the same wheel. And that's a big problem for this industry. We keep rebuilding the wheel and thinking again and again of different ways of doing exactly the same things, and not necessarily for the better, because after another 5 years or so we go back to designing once again, redesigning the same things. So I would like to put a stop as much as it is possible to this phenomenon. And so because of this, I think it's important to look at the fundamentals and understand them really well. That's why I thought, okay, let's revisit this dependency injection design pattern. And I'm not gonna go into the details of this meme because honestly I don't find it that interesting. Instead, I would like to go into an article written by Martin Fowler on 23rd January 2004. It was published, and it's an article that details dependency injection patterns, just so you can see how these cycles come and go. And because it starts with a very interesting introduction at least from a historical point of view. One of the entertaining things about the enterprise Java world is the huge amount of activity in building alternatives to the mainstream J2EE technologies, much of it happening in open source. A lot of this is a reaction to the heavyweight complexity in the mainstream J2EE world, but much of it is also exploring alternatives and coming up with creative ideas. So basically what was happening back then is that J2EE had come out with the enterprise Java beans, which many people considered really heavyweight. They were, let's say, a pinnacle of enterprise design thinking, which fundamentally what it does is it complicates everything. Sometimes for good reasons, but more often than not for quite bad reasons. So basically what would happen is that you'd have to write a bunch of enterprise Java beans, which are basically a lot of getters and setters, and then initialize them and feed them in together. You had to write a big XML file to mix and mesh them, which is why a lot of Java programming back then used to be writing XML instead of writing code. So what happened here is that other libraries came up in order to solve this kind of problem, and one of them was Spring, which obviously caught on because it's still used today. And the reason it caught on was that it was much simpler than the framework, the G2E framework. All right, so with this being said, let's go and look into some of the background for this. Here he's making a difference between components and services. Components, he ends up saying that components are local while services are remote, which is a good enough approximation. I think today this paradigm has shifted a bit, in the sense that we rarely have components except maybe on UI. But based on the design I see, most of the componentization and modularization in architecture is done using services instead of things like libraries or other kinds of local components like local OS services and so on. And then he gives an example that lists movies. So you have a class movie lister that returns a list of an array, actually, of movies. It has, well, the class has a method, movies directed by, that receives a string, presumably the name of the director, and returns an array of movies. And it says list all movies, find all, then iterates through this list, converts. This is another fun thing in Java. You had to convert to, even though you got a movie list, you had to convert to movie. So you convert to movie each element, and then say if non-movie get director equals arg, remove it and return the list. So basically take a list of all movies, remove all items from all movies from the list that are not directed by the director passed in as a parameter, and then return the list of movies that results. And of course, what it says is the implementation of this function is naive in the extreme. It asks a finder object to return every film it knows about. Then it just hunts through this list to return those directed by a particular director. This particular piece of naivety I'm not going to fix, since it's just the scaffolding for the real point of this article. The real point of this article is this finder object, or particularly how we connect the lister object with the particular finder object. The reason why this is interesting is that I want my wonderful movies directed by method to be completely independent of how all the movies are being stored. So all the method does is refer to a finder, and all that finder does is know how to respond to the find all method. I can bring this out by defining an interface for the finder. Public interface movie finder list find all. Now all of this is very decoupled, but at some point I have to come up with a concrete class to actually come up with the movies. In this case, I put the code for this in the constructor of my lister class. Then you have a class movie lister, private movie finder, public movie lister. Finder equals new column delimited movie finder of movies1.txt, which probably returns the... So it knows how to search in a column delimited file. Yeah. And then, of course, there's some implementation. If I'm using this class for just myself, that is all fine and dandy, but what happens when my friends are overwhelmed by a desire for this wonderful functionality and would like a copy of my program? If they also store their movie listings in a column delimited text file called movies1.txt, then everything is wonderful. If they have a different file for their movies, different name for their movies file, then it's easy to put the name of the file in a properties file. But what if they have a completely different form of storing their movie listing? A SQL database, an XML file, a web service, or just another format of text file? In this case, we need a different class to grab that data. Now, because I've defined a movie finder interface, this won't alter my movies directed by method, but I still need to have some way to get an instance of the right finder implementation into place. And so basically we end up with a movie lister that creates a movie finder implementation that implements the interface movie finder. And yeah, this is actually a pattern from a design pattern from patterns of enterprise application architecture. Enterprise, I think it was integration, if I remember correctly. His book. Let's just quickly check this out. Enterprise application architecture. All right. And this is a plugin design pattern. Basically, because what you can do is to load somebody can plug in an implementation for the movie finder interface and the movie lister will just work fine. Expanding this into a real system, we might have dozens of such services and components. In each case, we can abstract our use of these components by talking to them through an interface and using an adapter if the component isn't designed with the interface in mind. But if we wish to deploy this system in different ways, we need to use plugins to handle the interaction with these services so we can use different implementations in different deployments. So the core problem is how do we assemble these plugins into an application? This is one of the main problems that this new breed of lightweight containers face, and universally they all do it using inversion of control. So basically what happens here is that dependency injection is a design pattern that implements inversion of control. It's not the only way of implementing inversion of control, but it is the most common way. Now, why do we need inversion of control? Let's talk about what inversion of control is. So, and he gives a very good example. So what aspect of control are they inverting? This is the fundamental question. When I first ran into inversion of control, it was in the main control of a user interface. Early user interfaces were controlled by the application program. You'd have a sequence of commands like enter name, enter address. Think about your basic command line program and how you learned initially how to write code. You would probably write down, print line, enter name, and then try to read input for name, print line, enter address, and so on. So basically the program is driving the prompts and picking up a response. When you introduce graphical user interface, things change because the UI will loop through a render loop, and then he's saying your program instead providing event handlers for the various fields on the screen. So basically when somebody fills in a field, you could get an event. At least this was how it was done in desktop applications, right? And probably how it's done in mobile, because mobile is basically desktop applications running on a different thing. And probably how it happens with client-side JavaScript as well, because that's basically a desktop application running in a browser. So with graphical UIs, the UI framework would contain the main loop, and your program instead provided event handlers for the various fields on the screen. The main control of the program was inverted, moving away from you to the framework. You don't write a main method. Typically, you respond to events, so something happens. Think about your client-side JavaScript application. You have a form and you want to check, let's say, validate the fields before you do a post or something like that. Or maybe you don't even submit to the server, but you only change things on the client side. And what happens is that your browser is running a loop of rendering, and when I'm typing into a field and getting out of the field, the JavaScript code captures this event and I react to it, right? That's how this happens. And now what has happened a lot and what's different with web applications is that you have this separation between client and server, and you do something on the client, then you need to post things on the server, and then on the server you get the interface for the server is the HTML or the HTTP requests rather. Not necessarily HTML, but the HTTP requests that you get and whatever you are returning. But even there, if you are using an existing framework, presumably that framework is looping and waiting for things to happen. And you get an event when a post request comes. It responds to that with a number of operations and then gives control to you. So basically you don't have your main method, but you're just reacting to things, which this is what inversion of control means. The control is in the framework, is no longer in your program. For this new breed of containers, the inversion is about how they look up a plugin implementation. In my naive example, the lister looked up the Finder implementation by directly instantiating it. This stops the Finder from being a plugin. The approach that these containers use is to ensure that any user of a plugin follows some conventions that allow a separate assembler module to inject the implementation into the lister. As a result, I think we need a more specific name for this pattern. Inversion of control is too generic a term, and thus people find it confusing. As a result, with lots of discussions with various IOC inversion of control advocates, we settled on the name dependency injection. So this is actually introducing the name, as far as I know. So let's look now. The article goes into showing different ways of dependency injection. But fundamentally, what's important to understand is that dependency injection is not a framework and it's not a library. Dependency injection is a design pattern. You can inject things in a number of ways. You can inject, if we look at this style, so we have two classes, movie lister, movie finder. We want to inject movie finder into the movie lister class. And there are a number of ways of doing this. One is through the constructor. So we pass in the constructor, a movie finder. And here it's an interface, this parameter. The movie finder parameter is actually an interface. You can pass in a colon movie finder, a SQL movie finder, I don't know, web service movie finder, IMDb API movie finder, any kind of movie finder you want, with some limitations, of course, because, okay, there are some things you need to pay attention to. But this is the general idea, and the advantage is that you can also pass in movie finder test double, a stub or a mock. So for example, you could pass in a movie finder stub that when it calls find all movies by director or whatever it was, then it just returns a static list that you configure in your tests. And then you can make a number of tests, for the case it's an empty list, if it throws an exception, if it's a very long list, if it's a like 1, 2, 3 list, and so on. So then it makes testing very easy. It makes the code more expandable in the sense that you can now add a new feature in this application by changing only one of the classes. You could change the movie finder implementation or add a new movie finder implementation, inject it, and now you have access to IMDb movies, and it's just working exactly the same way. The code in Movie Lister doesn't change. So these are things that are interesting, I think. And there are a number of dependency injection patterns. You can inject through a constructor, you can inject through a property, or you can inject through a setter. Well, no, through a constructor, through a setter, so a property, or through a parameter in another method than a constructor. And these three, you should think about them in that they have very different semantics. If you pass something in the constructor, which is my favorite way, what this tells you is that this object can only work with an instance. So the movie lister can only work with an instance of a movie finder. This is very important. Well, how would you say? Without it, it won't work. So you have to pass it in. It's a must-have parameter for this object to perform its responsibilities. If you pass in as to a setter, then usually what happens there is that you have a default implementation, but you can override that default implementation with something else. But most of the times you're using the default implementation, and only sometimes you're using the another implementation. That's what the setter semantics is. And the third one is when you pass into a method. In that case, it means that only that method requires an injected parameter. So it's not mandatory for the whole object to function, but it's mandatory only for that method. One example here would be if you have a method that requires a logger, but only a specific method requires a logger, not the whole object requires a logger. So these are the different semantics of the different types of dependency injection. And if you go to the actual implementation, you can basically do dependency injection by hand. Right? You don't have to use any kind of framework, any kind of library, anything. And the next question is, so we mentioned that it's a very good dependency injection is very helpful for tests because you can inject instances for testing. But the next question is, do we need to inject everything? And that actually goes into another discussion, which is how much of, what is a unit that you need to test together. And here it's very interesting because naively you think that every class needs to be tested in isolation and you inject everything. That's a perfectly valid approach to start testing, but sooner or later you'll figure out that it results in much more tests than you actually need, and in a lot of work on maintaining the tests, or more work than you would actually need. So the key here is to separate based on behavior, and then for a specific behavior in your application. And what would mean a behavior is an input and an output, right? For a certain input you get a certain output when you call something specific. Think of these as different scenarios in your application. Like there's one scenario, let's say, to register a user, there's another scenario to log in a user, there's another scenario to change the user profile information. These are already 3 scenarios. You can treat them as 3 separate behaviors, and then you don't need to inject everything. You just need to inject the minimum necessary things in order for this to be tested in isolation for this behavior. Now, maybe you have 3 classes, maybe you have 1 class, maybe you have 10 classes. It doesn't really matter. Presumably you would want to isolate from input-output things like the database and other things. And you can do this with approaches like hexagonal architecture and ports and adapters or clean architecture. And when you are doing that, or functional core and imperative shell, these are all different ways of dealing with that. And if you're doing that, then what this turns into is that you only need to inject a minimum of things, basically the input-output classes, the ports, the adapters, stuff like that. Probably only the ports. The adapters can still be part of your behavior. Or you can test the adapters with the ports in the same unit and test the inside logic in a different unit. And I think this is where a lot of dependency injection has gone wrong, because we have gone into using these dependency injection, these big frameworks like Spring, and you inject everything and you do auto wire, and on one hand it's good because you can change everything in your code. You can replace every interface with an implementation or with another implementation, but honestly it's too much. We have gone all the way to the other side. So from wiring everything together with new and singletons and factories and things like that, we have gone completely the other way and wiring everything automatically through a framework. And when this doesn't work, we don't understand anymore why it doesn't work. So the key here is actually moderation. And moderation starts with understanding what dependency injection is, that it's a design pattern, it's used for inversion of control, it's incredibly useful for testing, but it doesn't mean that everything needs to be an interface. And even if the interface only has a single implementation and you always use that implementation except for a unit test that doesn't actually test anything useful, because you are basically just testing that things are calling each other correctly. It doesn't make sense. So instead, what we want to have is to minimize dependency injection and to use it just in the places where it makes sense, where we really want to have this dynamic behavior, where we want to inject and configure our core software with different plugins. And one of these plugins is for testing. So, and now what's interesting to me is that Martin Fowler also describes another approach, which is a service locator. So the basic idea behind the service locator is to have an object that knows how to get hold of all of the services that an application might need. So service locator for this application would have a method that returns a movie finder when one is needed. Of course, this just shifts the burden a tad. We still have to get the locator into the lister, resulting into the dependencies here, where you have an assembler that creates a movie finder implementation. Depends on the interface movie finder. You have a service locator that knows how to search for movie finder, and the movie lister, which will receive as parameter the service locator. I honestly don't find this useful at all. I've seen this pattern, but it really bothers me that you have the service locator everywhere, and the only thing you're using it for is to say load new column movie finder or something. Get me a movie finder. I like the other approach better, which is with smaller objects that are very specialized, but also combined with using a very clear, small classes. So actually small modules per behavior. Don't inject everything, because you don't have to inject everything. And of course, with the locator, he talks also about that there could be a segregated interface for the locator, and you could have a movie finder locator, and then you'd have a class service locator that probably implements a bunch of interfaces. And then you can have it dynamic and so on. But honestly, this whole article is very interesting, and in the end it talks about the different types of injection and how they make sense and how you could use configuration files and so on. But I think that the core thing here, and something that I hope I made clear in this video, is that dependency injection is good when used carefully, right? And this is one thing about testing and test-driven development. There's a style of test-driven development in which we try to avoid using mocks as much as possible. Mocks being, I have to define mocks as well, mocks being the objects that check, or the test doubles that check interaction between two classes. So, because everything is now called a mock, although some of them are stubs, some of them are spies, and so on. We can avoid this problem. So we can, by trying to reduce the number of mocks that we use, so the number of checks in calls between different classes in collaboration tests, we end up with small modules inside our application that are tested together through only data-driven tests. Like there's something in, you get something out. And that is a really, really good way of testing. And it leads to designs that are kind of decoupled inside, because you have these and the small modules per behavior that are split through your application and that you can test in isolation with a small number of data-based tests and state-based tests. And they lead to these kind of designs where you don't actually need a lot of dependency injection. You just need dependency injection, the integration between modules, the input point or plug points for plugins, right? And that's a design that you should strive for. from my opinion. All right. What do you think about all this? Have you seen code that overuses dependency injection? Have you seen code that is really good and that doesn't use dependency injection at all and is very testable? That would be interesting to see. Let us know in the comments and let all the other people watching this know what you think and what you have seen. We love seeing comments, we love answering to them. So yeah, don't forget to leave us some comments. Thank you kindly for the view, and until next time, remember to think, design, and work smart.